Okay, well. The assignment was on the quadratic formula, okay? That was the first assignment that's due today. The second one was on complex numbers. We're gonna focus on the quadratic formula and then we're gonna work into complex numbers, okay? Hang on a second, I got a question here. Okay, so here we have the quadratic formula. We're having trouble with this, okay? Have trouble identifying the things we need to identify. So we take our 3x squared. Now, is this in the form ax squared plus bx plus c? Okay, well, yeah, this is. This is. And a is 3, b is 6, and c is -1. I didn't really look to see if you were using the negative on the c, but that's what it has to be. Okay, because if it was +1, we'd have a +1 here. C is -1. If you add a -1, it means you're subtracting 1. Okay, so now that we've identified A, B, and C, and a common error. Okay, common error is A is 3x squared. B is 6x. And C is negative. Okay, there's no x in A, there's no x in B, there's no x in C. If there was, we wouldn't have a quadratic. If A was 3x squared, then when we plug 3x squared in for A, we'd have 3x squared times x squared. That would be 3x to the 4th, not 3x squared. So the only thing we can plug in for A that gives us 3x squared is just plain old 3. Let's emphasize that because it's a very common error, and some of you made that error. Okay. A equals 3, so we plug in 3 here, and we get 3x squared, right? Okay, so anyhow, A, B, and C are just numbers, or sometimes they're symbols, but right now they're just going to be numbers. Okay, so I won't say the solution is, I say the solutions are, because there's a plus here and a minus. There's one solution for the plus, one for the minus. And we didn't really go that far because we wanted to just work on the substitution. Once the substitution's done, the rest is just plain simple arithmetic, okay? And nobody's going to have any trouble with that. But we're going to say now the solutions are x equals -b. Well, b is 6. Then we have b squared. Well, that's going to be 6 squared. And then it's going to be -4ac, so that's -4 times a, which is 3, times c, which is -1. All that over 2 times a, which is 2 times 3. Now, is that what you got? Except for maybe the -1 here. You got to be careful. You know, I saw one case where somebody plugged in the b here because you're almost done and you got careless. Okay. Well, you see me do it all the time, so don't feel bad, but you know, you're not going to get it right unless you're careful. Okay. Well, now what do we do with this? We're going to take this on another step and we're going to evaluate this. And I could ask you to do it. I don't think anybody is going to have any trouble evaluating this because we've got -6 here. We got plus or minus the square root. 6 squared is 36. 4 times 3 is 12, times 1 is still 12. And we got 2 negative signs, so that's going to be plus 12. And all that is over 6. Well, that's. I'll do it this a couple of ways I could have written that out. I think this will work best for you. Okay, here's. -6 plus or minus square root of 48 over 6. Okay. Now, from what we did last week, we spent most of the week on it. You should understand. And if you don't feel bad, just make sure you go back. Nail down what we did last week. Okay, we got -6. Okay, the square root of 48, you can do prime factorization. You're going to get 2 times 2 times 2 times 2 times 3, which is 2 to the 4th times 3. Okay. So I'm just going to kind of write that out to the side to remind you. I'll just write it out over here. You do prime factorization, you're going to get 4 2s and a 3. And the square root of 2 to the 4th. And the square root of 3. Then by grouping the 2 to the 4th, we group 2 of them and 2 of them, and we get 2 squared squared. So this is 2 squared times square root of 3. Make sure we see that square is on 2. And that's 4 times the square root of 3. And then that equals as much room as I can, -6 over 6. Plus 4 square root of 3 for 6. And then the 4 over 6 reduces down to 2 over 3, not 2 over 2. Okay, so that's all just arithmetic. You know how to do that. You know how to do all those steps. Now, you might have to look at some of the videos and kind of review it, but we've been through all that and you will do a pretty good job with all of this. Okay, -1 plus or minus 2 squared of 3 over 3. Now, we use the plus and we use the minus separately. Say it's -1 plus. Two square root of 3 over 3. Or -1 minus. Two square root of 3 over 3. So now there are 2 solutions. Here's a solution. Here's a solution. If this is done correctly, if you plug this into the equation, you're going to end up with 0. If you plug this into the equation, you're going to end up with 0. Okay? That's the whole picture of how you use the quadratic formula, at least for this purpose, for the purpose of solving an equation with numbers. Okay? Now, all this from here down to here is pretty easy. It's actually pretty easy to figure out what A, B, and C are and plug them in. Things not always easy is to recognize when you've got a quadratic function. But once you recognize you have a quadratic function and put it into the form ax squared plus bx plus c equals 0. The rest just takes practice. You do a dozen of them and you know it. Then you do 20 or 30 more and you know it well enough to pass an exam. Okay? Because after you know it, it becomes really quick and fairly easy just to do the substitution, and the arithmetic doesn't take long at all. Okay, well, that's where we are. Let's see how we execute it in a couple of these examples. Okay, so I'm going to do the same thing with this equation, but this equation isn't in this form. Let's be sure we understand what to do now. Two x squared equals 5x plus 7. It's not in the form. Okay, put it into that form. I'm going to do it in one step here. I'm going to say, well, I just subtract everything on this side from this side. That's going to give me 0 on this side. If the equation is going to turn out to be quadratic, that's all you need to do. Just whatever's on one side, and it could be either side, but usually it'll be what's on the right side. You just subtract it from both sides and you get 0 because that's the key. You got to get this to equal 0. If it isn't a bunch of stuff equal to 0, it's not in quadratic form. And of course, if that bunch of stuff doesn't have just an x squared, an x, and a constant number, it's not in quadratic form either. So there's an x cubed there, it wouldn't be a quadratic equation on it. Okay. Okay, so strategy is just subtract 5x plus 7. Well, no, here we subtract 5x plus 7, both sides, and that gives us this. And we write it out. And then we say, well, right hand side, we got a 5x minus 5x, we got a 7 minus 7. 5x minus 5x is 0, 7 minus 7 is 0. Then we've got 0. Now this is in quadratic form. So this is now really that kind of sloppy. It didn't have a lot of room, but it's now the general form of a quadratic equation. So now we can substitute. We want to write the thing out because we're going to get used to writing it out so that we are more likely to remember it when we need it. Now over here, purple, I'm gonna write out. A equals 2, B equals -5, C equals -7. Then you want to write that out. You want to do that step. Again, when you're first learning it, you want to do every step, even when it gets a little bit tedious. Because you have to keep reinforcing it so you'll remember those steps tomorrow. And you want to reinforce it a little bit tomorrow, a little review. And then you're going to probably end up using it in future assignments. Then it'll reinforce itself again, then you review it for the exam. Okay, and that's how you get it in your head and get the whole process done. And of course, you do enough of these problems, it works out. Okay, so anyhow, we substitute -b, that's negative of -5. We're running a space problem here, but let's see if we get it. And then b squared, you square the -5. Now there's another pitfall. People want to square the 5 and leave the negative sign sometimes, okay? That's why you put parentheses around the -5, so you know that you're squaring the whole b. And you know if you square -5, you get 25, you don't get -25. So there's a common pitfall, you want to avoid that. Then it's -4 times 2 times -1. All that over 2 times 2. Make sure that's right. Negative of -5 is 5 plus or minus square root of. Square -5, you get 25. 4 times 2 is 8 times 1 is 8. You got a negative and a negative, so that's going to be +8 over 4. Now, there's nothing fancy that can be done here. Nothing reduces 33 factors into 3 times 11, and that's it. And you don't know, you don't have an exact value for the square root of 3 or the square root of 11. So you just leave that as 33, okay? The solutions are x equals 5 plus the square root of 33 over 4. And x equals 5 minus the square root of 33 over 4. Sometimes you want to list the solution set. Okay, now we've already seen absolute value equations where you get 2 solutions. Okay. So we put braces around this because that's how you indicate sets. It's a solution set. It's a set, so we use braces. Then we list the solutions. Then we can approximate the solution. Square root of 33 is 6.7 roughly. So if we plug these into the calculator, these are exact. These are the exact solutions. The approximate solutions, I'm going to do this in my head, and that's always dangerous, but we're going to get like 11.7 over 4, which is 2.925. I'll call it 2.93. Uh-oh. I said 6.7 is 5.7. What I'm looking at is 33 is between 25 and 36. The square root's going to be between 5 and 6. So I've got this one. Possible to be good. That would be 10.7, and I did something dumb there too, but you're going to get it's very approximate, something like 2.67, and negative. That's clicking very fast. 5.7. And a big question mark on that. Plug it into your calculator. You get something in the general vicinity of that. The reason I wanted to approximate it. Got the number line. 0 here. 1, 2, 3. -1. 2.67 is going to go about here. And -0.175 is going to go about here. And at this point, that's pretty much everything you'd want to do with the series for the quadratic equation. Now, right now we're introducing a thing, although there wasn't a sign to do on it. We see how to rearrange this equation into the form of a general form of a quadratic. We see how to identify A, B, and C and plug them in. And once you plug them in, you just do the arithmetic and you get this. Then maybe you write that down as a solution set. Maybe you don't have to do that right away. Open Math probably doesn't ask for the braces. So just list the solutions. And those would be the solutions. Maybe they ask it to approximate the solution, so use your calculator and get approximate solutions. Don't do it in your head because I'm not all that sure of my solution. Actually, let's see, I can get kind of sure that'd be 2.5. That should be 2.25. So those aren't right. Thinking that should be I'm not gonna do this. Okay, my mental arithmetic failed me there. Those aren't too far off, but they're not particularly accurate. Good. Nevertheless, plug into your calculator, get the two solutions. Open Math might ask you for this, might ask you for this. They're not going to ask you to graph them, but I threw that in because it's okay. And you should understand where numbers lie on the number line. All right. Now with the third equation, first let's see if we have any questions.
I got the 25. Oh. Sorry.
Yeah. Okay. Okay, somebody's confused on why I don't have a -7 here. Because everybody else has got -7 here. Well, it's because I picked up the -1 over there. My eye caught it, and I was careless. It should have been -7. Okay, and that would make this. Let's fix it. Actually, fairly easy to fix. Okay, well, that's going to be 20, that's going to be 54, 56. It's 4 times 2 times 7 is 8 times 7, which is 56. And then 25 and 56. I'll be darned. It's 81. So actually, that ain't possible. Okay. Check my arithmetic again. That's 25. That's 8 times 7 is 56. 25 and 56. 20 and 56 is 76. 5 and 6 is 11. That makes it 81. We got a perfect square root. Okay. So say I pretended to make a mistake here. And okay, wait, maybe I did something else wrong. Okay, so all of my 33 should be 81s. But of course, the square root of 81 is 9. But we no longer have square roots. So what I was about to say is, I pretended to make this mistake just so I could put those square roots in and see that you usually get them. Actually, no, I made that mistake. Okay. So take it for what it's worth. We got 5 plus 9 over 4. That's 14 over 4. Okay. Which is 7 halves. And that makes sense by the rational roots there. Okay. I just wrote those numbers down, figuring, well, no way we're going to get a rational solution, but we did. Okay. And don't worry about the rational roots. That's what we're going to worry about in this course. Worry about a little bit in pre-calculus course. This takes you up to what you need to understand from pre-calculus. Okay, anyhow, then we got 5 minus 9 over 4, which is -2. And that shouldn't be -1. Okay. We violated the rational roots there with -2, and that's again something that you might well pick up in calculus. Out in the real world, rational roots theorem is pretty useless. Unless you're studying Galois theory or something. That's advanced. Would believe on this topic. I mean, I believe it, but through it. Okay. That's like a senior level undergraduate course for math majors at good institutions. Okay. I'm just saying rational roots through. Okay, so now I can write exact solutions. Down here, when I had the square root of 33, I didn't have exact solutions. We just had a little overkill. Okay, so I'm just looking at something up there, making sure the solution is correct. These two numbers should average out to 5/4. So I just wanted to make sure they did. Or I want you to trouble writing these things down. I usually will write the negative before the positive, the lesser before the greater. I'm writing them down in the order I chose to write them here. Probably not a good solution. So we don't need to do an approximate solution set. Since we got an exact solution set, there's no need to approximate it. Okay, on the number line, 7/2 is 3.5. So we can put 0 here, 1, 2, 3, 4, and then -1, -2. 7/2 goes about here. It's 3.5. -1 goes about here. Now, there's something we might later do. So it's good to see this at this point, so you can kind of get used to the idea, but don't let it distract you from the fact that the plug in correctly. This all works out, in this case, very nicely. More nicely than I intended. Because usually, unless you have contrived problems, you're gonna end up with something like what we have here with the square roots. You can't simplify. Okay. Now let's look at the third example. Okay, the third example is 2/x plus 3x equals 9. Given the limitations of my handwriting, I'm not sure why I want to have a nice clean board, but it makes my bad handwriting a little bit easier to read, so I guess I can point to it. Okay, this is not in the form of a quadratic. When you see this equation, you won't even necessarily think about a quadratic. But the one thing you think about when you see an equation with denominators, aha. In this case, just the denominator, but you could have more than one denominator. Overfly. Those sides by the common denominator. No way to rescue that. In this case, the denominator is just x. Okay. When you see denominators, you have to have this reflex. And it's, as I've said a couple of times, one of the tough things to convince people to see. Okay. So we multiply both sides by the denominator. X. So I'm just gonna write now. I'm gonna write this. And you should write this too. Whatever you're multiplying by, write it and put the whole side in parentheses. Write it here and put the whole side in parentheses, because otherwise you might just end up multiplying this by X and forgetting to multiply this by X. And that screws up everything. If you don't multiply everything by X, the equation becomes unbalanced. That's why the rule. Okay, well, that gives us X times 2 over X, which of course you probably want to write carefully. I'm going to skip a couple of steps that I've been including. I'm going to write it as X over 1 times 2 over X. Okay. Because then we see we can multiply this as a fraction, giving us 2X over X. And then we know that we could write this as 2 over 1 times X over X. And X over X is 1. Since we can do that, you can say the X's cancel, and we get 2 plus 3X squared equals 9X. Okay, so well, let's write that now. We got 2 plus 3X squared equals 9X. We have another aha. It's a quadratic. I want to put this in general form. So we have subtract 9X from both sides, so we're going to get 0 over here. The whole goal is to put it in the general form, which has equals 0. I emphasized that in the previous solution. So we'll write it out now, and we can put this into the form. 3X squared minus 9X plus 2 equals 0. This is AX squared plus BX plus C equals 0. A equals 3, B equals -9, C equal to 2. So our solutions are X equals negative of -9 plus or minus the square root of -9 quantity squared minus 4 times 3 times 2 all divided by 2 times 3. Now at this point, we're just down to simple arithmetic. 4 times 3 is 12, times 2 is 24. 9 squared is 81. So that x equals 9, is negative 9 is 9, plus or minus the square root of 81 minus 24, all divided by 6. (81 minus 24 is 57. And 57 is 3 times 19. Prime factorization is 3 times 19. Neither one of those numbers breaks down. There's nothing you can divide into 19. And you don't know the square root of 3, and you don't know the square root of 19. The calculator knows it to a high level of precision. It can approximate it, but it can't write it out exactly, okay? So we could write that as 9/6 plus or minus the square root of 57 over 6, which comes down to 3/2. Plus or minus square root of 57 over 6. Square root of 57 is probably about 7.6. So that could be approximated, but since I apparently am messing up on arithmetic, 7.6 over 6 is like 1.27. Okay, it's like a plus or minus 1.27 there. That's like a 1.5, and you get the numbers, but we're not going to mess with it, especially since we're out of time. Okay. Now, one comment that leads into the whole idea of complex numbers. If this number here is negative, but otherwise bigger than this number, you could get a negative under here. Right now, it's 81 minus 24, that's a positive number. If it was 24 minus 81, which it isn't, but if it was, you'd have a negative number under here. If you had a negative number under the radical, that's where you get the complex numbers, and you probably want to review the video from last time. And or check out Open Math. Okay, check out quadratic formula anywhere on the internet. And the top options are probably going to give you pretty good stuff. Okay, want to understand all that. And we'll continue the assignment on complex numbers until next time. Let me take a quick check here. Give you some idea how I'm going to rearrange the assignments based on what we see today. Okay, we'll see. I'm gonna probably insert another assignment between Wednesday and Monday, okay? In addition to the basic functions, toolkit functions. That one's pretty easy, but you want to remember those things, okay? They're going to be very important. They're the functions you build pre-calculus on. So at that point, we're starting to see why we do some of this stuff and starting to get a little bit of picture of what pre-calculus does, because it's an important picture. I think it's going to be helpful to you when you start a pre-calculus class. But I'll make judgments, again, based on what we're seeing about just exactly what I include, okay? So I'm going to go from there.